You're muted, Ola. Ola, I think you're muted.
Trying to connect it to my headset.
Now we can hear you.
Okay. I don't know why my headset doesn't want to work.
Okay.
But see, others are coming in. Oh, now I think I'm on top of mic. Oh, now my sound should go through from my telephone. Good. Yeah, everything seems to be working. So
Okay, I guess it's 1 o'clock, so we can start. So today's online training, we're joined by our co-founder and CEO, Ola Green, who's joining us from his remote control tower, air-conditioned, fully heated control room for his robot. So he'll be showing us some of the new features of the that we've been releasing today, available to everyone, and kind of walk through a few of the things and show us what advantages we can have of going to the field. Okay, so I'll just pass over to Ola.
Thank you, Gareth, for the nice introduction. Yes, and as you can see, I'm sitting here in my car. The spring is not quite to feel yet, though the soil has been defrosting. So what today we would like to show you is some of the new features demonstrated live. Therefore, a bit nervous because it's always interesting to see if everything is running when you do everything in live. But what I have is I've logged into the meeting twice, and I can actually share you. So bring my computer in. So I have also logged in with my user account, and we'll just share with you briefly what we will be doing. So now I pull up my interface. You can see I've shared my laptop screen. In that one, I am parked almost next to the robot in the bottom or top left corner. In the plan, you can see right now the robot Green Agro PR22 is online, standing in idle. We have it within the Robotic Live. It has a plan prepared where we will show especially some of the new features that goes to the implement control. The robot is equipped today with a stubble harrow, where it will be doing stubble cultivation with 5 kilometers per hour in something around 14, 15 centimeters depth, to show even with the less traction capability that the 150D has, that we can actually, with dynamic lowering of the implement while moving into working, enables us to actually do also more heavy tillage operations, because we don't lower the implement and then start off in a hard push, but enables the implement to do. It is a feature that has especially also been requested for when we do seeding, so that we don't lower an outlet of a seed drill into the soil, getting it filled with soil before it moves. So especially in seeding operations, we've seen a huge benefit of it. But what we will show today is the robot running here with that. So the plan, you can see it has 6 passes where we are doing zero turn, and at the same time also working in and out of the field. So to get something starting, I will bring the laptop to the field, and then I'll come back to sharing the screen with you in a moment. So we'll go to the fresh air. See, we have the robot here. So again, you can see the robot plan has been loaded. So we should be able to press start, and then we choose our operator and confirms, and then we allow the robot to start when it hasn't been parked for. That's the thing when you learn. So you can see with your remote control that the battery ran out, of course, just as I was about to start. So I have the extra battery in here. So the remote control is starting up again. We are locking in with the remote control, and allows us to start the robot. we can start the plan and go to our auto mode. Resume the operation and start it. And then the robot is planning its route. And that's where one of the new features is, as soon as one green line has been calculated, then you can start up the robot for the operation.
I can see we lost Ola for a few seconds there,
Sorry,
but he seems to be driving now.
That's where when I'm using Teams on my telephone, I had an incoming call, so that took my internet connection. So that was why it froze from here. What you see now is the robot moving towards the first line, where it's now turning the 0-point turn. And you will see the implement slowly being lowered while it's moving into the work. And as the implement reaches its full depth, then it's starting to work full speed. What you could also see is that when it enters into the bed system, then the light was turned on from the crop eye camera so that we can see both crop eye and implement now in full working. So the robot is here working with the speed of 5 kilometers and approximately 14, 15 centimeters working depth of the stubble cultivator. So while the robot is moving away from me here in the background, go back to the laptop where we can follow it. And I see some of the elements where we are gathering data in from the robot, with especially from the camera, where we can see the features from the crop eye, that we have the live features coming in from the camera. So in a moment, when I get into my car, we can share the screen. Good. So what you can also see now is the robot moving along its road, getting to the end of the first pass. We can see 14% of this small task has been covered, running around the 5 kilometers per hour, now stopping increasing the implement while getting to the point where it will be doing its 0 turn. We can zoom a bit in. And see how the robot is now following the line. At the same time, you can see the pictures also changing from the crop eye. So the crop eye are with 5 to 8 seconds interval uploading the recent picture from the crop eye camera, which can be seen so that we have a possibility to see actually also the conditions straight down in the field. Now it's gotten to the second row of its path, the third row in this plan. And that's where we can scroll a bit down here on the menu, we can turn on our coverage to see how certain plots have already been implemented or been treated. We can also look at our plan info, see that we are running with our stubble harrow, the robot that this plan is made for. We can see the implement detail is the important thing, where in this new feature, our implement design looks a bit different than before. We have some basic features with an implement name, implement type, and as you will see, we have added a couple of new headlines, especially the harrow is one of the new features coming in. Standardly, we've had before offset from GPS, width and length of the robot, of the implement as standard. But now also we have a setting that is called work setting from for the implement, where the hitch height is set and the speed. What I did in my first test run, I tried to push the implement to the depth, so now the lift arm is actually fully down with this drill or harrow. So we have the speed and the hitch, and then you can see hitch height and speed for non-working. And then the new one that is called additional setting, and that's where you actually put in a tick mark when you create the implement that says if dynamic hitch control should be enabled. And that's the on feature, which you have. Then show you, so now you can both see from my small camera view that the robot is getting to the end of the row. And as it exits the field, it's raising the implement and getting to the point where it will be doing the zero turn. So you can see both for both views that we have that element where the robot is now doing the zero turn. Moving into the next row, you can see it will go one row to its right. We can have the front camera also activated, so we can see a new feature to explain a bit that we give it a number of attempts. So here we have the live feed also from the front camera of the robot. Now it's hidden behind the trees, but will come out in a moment. The other element here, standardly we have with the telematics. Now the robot we are using today in the field is one of the 150D models, where you can see left and right engine. So the left engine of this robot has been running 205 hours. The temperature right now is 81 degrees, and it's running with just a little bit less than 2100 RPMs. We can see the implement has now started to work again. So robot is now moving down the field. We can turn on our rear camera and also have a viewpoint to the implement as it works. So typically we see that this takes 2 to 3 attempts, a bit on the connection rate, but that's where we can see Robotti running down the field with the coverage and also the element where we see it in working position. So for the things what we see when we are operating with the robot with the new features for the dynamic control enables us functionalities with new implements that needs a moving element so that we move the implement while we put it into work. That can go for like the stubble cultivator as we work with today. But as mentioned initially, seeding is important that we can lower the drills. We have seen that for some customers around the world that has that need so that we minimize the risk of blockage of the outlets. But it's also features where, for an example, if the type of implements give you some pre-settings. So mentioned with this implement we're running today is a harrow. We also have with a sprayer, where then the planner knows that we do not have to change the hitch when we get to the headland. It's more turning on and off a sprayer, for an example. So now we see Robotti getting to the end of the row, where the functionalities for the robot has that with the zero turn. We could also do it with a non-zero turn, and for the LR especially, we would say works with hydraulic. Good, I think it's back again. Now that's the problem with Teams and ingoing calls. Our recommendations right now is that for the LR works equally as good with both zero turn and non-zero turn, but for the 150D, its hydraulic is not as fast when using non-zero turn. So that means if it's doing steering at the same time as doing a large movement of the hydraulic, the speed on the headland should be lower to make sure that we have a sufficient amount of hydraulic to make sure that we can do an accurate operation when we get to the headland.
Users can also increase the lead out and the lead in on their plans to compensate for this as well, which will give them a little bit more time going straight out of the plan and into the plan, which gives it time to raise the implement if it wants to do it in a continuous way.
Correct. So I will go to the robot, so see if I can catch up with it when it comes down a number of rows further out. So we have the robot moving down the field, and where we should be able to see when it gets down. I know there's a bit wind in the microphone now. But while walking here, we can show this is from the strip cropping field where we have a number of different crops. We test with these rows of berry bushes in between. So that's where robotics is being tested for multiple tracks. And we see body coming down the field with implement full depth. And now turning off the camera right now, and then increasing the lift, getting to the point where it should do the zero turn, waiting until the implement is fully up to make sure that nothing is broken when it gets to zero turn, performs the zero turn, and will move towards me. And then robotic has to go for its last pass. And you see now the lift is starting to be increased. So the tines are going into the soil. So making sure that it's a full working depth when it gets to the full gun. The camera in the moment turning on the light for the drop eye camera. Of a couple of the other important functionalities we have now is the ability with the mobile phone connected, where we open the terminal from the mobile phone. We can do depth adjustment and speed adjustments on the go. So being in the field and seeing that, okay, the plan was maybe made for 4 kilometers per hour, we can adjust the speed of the robot to maybe 3.5 if we can see that needed. But we can also change the depth. So if instead of running maybe 33 centimeter in lift setting, we can increase it to 40 as examples. So these are some of the functionalities that enables us as operators in the fields to do some adjustments to the plan that has been made without having to create a new plan. So being almost back in my remote control tower. I will just pull up the screen again. Yes, so you should be able to see it. We are almost finished. I will zoom out a bit. So we have to do one more pass for the robot to get down to us. Where we are parked here, started out the green flag, and then the robot has a finish point here next to the trees. For the crop eye setting, you will see that in we've been asked if we're still watching, that we have two camera functions. We have the front camera and the rear camera as two elements we can select. And then for the robot, software is now prepared so that we can add an extra camera on the implement as an additional. This is something we will test with certain operations, certain customers during the season, where you will have a more direct view down, depending on where this additional camera is mounted. But it's a functionality that is seen now in the interface. We can see Robotti lining up for the last pass. And the last element I will show when we get further down is also that as part of our extended remote access, we can see that we of course have the camera. Before you saw the car coming by on the next to it. So we of course have the different camera surveillance elements as well as this. The 150D that we are operating here does not have the ability for the disconnected remote control, but this is one of the new features for the 2024 that is also mentioned as a safety element so that we can actively disconnect our remote control and only perform a remote supervision of the robot. And we see also from here that we have almost finished, so 93% done until now. Provide continuously sending in our pictures. I think separately, Gareth has also taken you through in another of our online sessions the functionalities with the crop eye and the mapping services. But this is something where I have, as a baseline, always activated the camera to make sure that with highest possible sample rate, we collect the pictures. So we see the robot coming down, and I will just, with the shared screen, go to showing that we can do a stop Robotti remotely. And we can see we have a parked robot that immediately accepts out in the field, so that the remote stopping of the robot is a way for us that as part of this extended monitoring, that we can also do this from both a mobile interface as well as from the laptop interface. I think that was more or less this small plan and program. So opening it up for questions, comments, etc. from the attendances.
Yeah, I wanted to just make a comment, as I said before, with the 150D and the dynamic hitch control. The hitch is slower than with the LR machines, so it might be necessary to increase your lead in or lead out in the planner, so that you have enough room to move into the area, enough room lowering the implement when you're coming into the area. The robot will travel at its non-working speed while it's lowering the implement until it gets into the area, when it will then change to its working speed if they're different. So you could put a low non-working speed on as well, which would also give it more time driving over a short distance to lower its the implement. We do some adjusting of the speed when it's in non-working to be able to lower the implement in time, but with, yeah, as I say, with the 150D capabilities, it's a bit more hard.
We really hope that with these extended possibilities for setting up more dynamic features with the implement, that it also gives the operator that feeling that you don't have to go back and do a lot of this replanning that might have been needed beforehand, but that you can really do the adjustments in the field, looking at the soil conditions, the tool, how it works, to make these final adjustments in depth and speed, where we know these are the important factors when we're in the field at specific field conditions on the day where we're executing the operations. So for sure, elements that we see not only bring that flexibility as operators, but also enables this for the seed drills, for example, that previously have had that need of dynamically lowering while we move into the field.
And although Ola didn't show them when he was starting the operation, there is the new starting options where you can set where you want to start in the plan, if you want to skip a number of rows, and then if you only want to work a number of rows or an area, which again adds to the flexibility of the plans and means you can do more in the field rather than having to go back and create a new plan if you only want to work a certain amount of rows. It can be, yeah, very useful when we're doing seeding. If we know that seed is only going to cover a certain area, then we can have the robot return to the seeding place as well.
Good. I think, Gareth, then we have at least tried also a live demo, with just really live from the field with everything that comes with. Thank you very much for logging in here to my remote control tower.
And thank you very much for presenting today. Okay, so if there's no questions from anyone else, I think we can say thank you and goodbye. Goodbye.
Thank you. Bye.
Thank you, guys. Bye-bye.